A warm welcome to the presentation. Today we are going to see a small case study how this pneumatics is used in solar PV cell manufacturing. So the industry taken is Tata Power Solar, and the course in which this case study plays a main role of learning is hydraulics and pneumatics. So the solar panel manufacturing company was facing the problem in transferring solar panels from one station to another station. The solar panels are made up of glasses and it is very delicate. So much of the time while transferring it was breaking. So we understand these are all the challenges which is faced in the solar panel manufacturing company, photovoltaic cells. The wafer which is used is very delicate. The company was breaking more panels than they were manufacturing. Also, they were facing the problem of transferring the huge dimensioned solar panel. So the 14-inch diameter parabola-shaped glass bowl solar panel they made was very delicate. So every time while transporting, it was being either dropped or being squeezed to their breaking point. So all these panels will go for a ductile or a brittle fracture. Anyone in the class? Yes, it is a brittle fracture which cannot be used further. So they were disappointed with the downtime and the broken product that they have suffered with what had been made commercially available. So most of the available grippers in the market was not able to handle the fragile glass. So while transporting the glass materials, we may use some robotic grippers. So that is not able to handle the glass. Also, magnetic pickup and transport is not possible as the glass is not magnetic. So normally we transport materials using magnetic clamps where the ferromagnetic property is used to stick onto the material which is to be transported. So let us see how this challenge can be addressed. So the objective of the case study is to find a solution that must cater ease of transportation of glass materials during manufacture, low cost involving the manufacturing process. These two are the major objective of this case study. So here is a three-dimensional view of how solar panels are made. So normally crystalline silicon photovoltaic module manufacturing line consists of simulation, junction box, framing and trimming process, lamination, and uh, bushing preparation. So the finally after assembly, testing and sorting the materials will happen. So the thickness of the solar panel is 2.5 mm to 4 mm and it is made up of glass, a fragile material, polycrystalline, monocrystalline, thin film. We have three different kinds of material here. So the solution is the pneumatic grippers were used, which is specifically a type of pneumatic actuator that involves either a parallel or angular motion. The tooling jaws, fixtures, or rubber suction diaphragm that will be grip the object like this. So usually we play with children. We have some gun and we have a rubber bush which will be acting as a bullet. When we point this gun towards the glass and then shoot it, it will go and stuck due to vacuum created in the cup. So in the pneumatic grippers, vacuum is created in the rubber cups by creating pressure difference with the help of force from the compressed air by the compressor. The gripper is placed directly on the product and with the vacuum generator, the rubber cup creates sucking action which in turn grips the object firmly and tightly. So this is the best possible solution that can be used to transport all the solar panels manufactured in the manufacturing line. Here is the view of how the suction cups work. So the person who is working here on solar panels will transport this whole assembly, this total assembly with the help of pneumatic compressed air So this compressed air is produced from the compressor, and we have a direction control valve and a vacuum generator. The air line is there, and we have suction cups here, all of made up of rubber, fine smooth rubber, which will not damage the glass materials. So this is how pneumatics can be effectively used in transporting photovoltaic cells in a manufacturing line of a solar panel manufacturing company. So I hope everyone understood the challenge as well as the solution given. Let me summarize this case study. So the case study was taken to transport solar panels, PV panels, transportation from one station to another station in manufacturing cell. So since we have a lot of grippers in the robot arm, there needs a special material that can take these solar panels without breaking. The major cause for the problem or the major concern of the company is breaking of lot of solar panels. So here we use suction cups, which uses pneumatic air, which is a compressed air from the compressor that holds the solar PV panels for transportation without any damage. Hope this case study is interesting for you. Let me see another case study. We'll meet you again. Thank you.